Abu Abdullah Albatani, 868–929 CE. Abu Abdallah Muhammad ibn Jabir ibn Sinan al-Batani al-Harani was born around 858 CE in Haran, and according to one account, in Batan, a state of Haran, Batani was first educated by his father Jabir ibn Sinan al-Batani, who was also a well-known scientist. He then moved to Raqqa, situated on the bank of the Euphrates, where he received advanced education and later on flourished as a scholar. At the beginning of the 9th century, he migrated to Samarra, where he worked till the end of his life in 929 CE. He was of Sabian origin, but was himself a Muslim. Al-Batani is sometimes known by a Latinized version of his name, variants being Albatanius, Albatani or Albatanius. His full name was Abu Abdallah Muhammad ibn Jabir ibn Sinan al-Raqi al-Harani al-Sabi al-Batani. Al-Batani was born in Haran, called Kari in earlier times by the Romans, which lies on the Balak River, 38 kilometers southeast of Rafah. His family had been members of the Sabian sect, a religious sect of star worshippers from Haran. Being worshippers of the stars meant that the Sabians had a strong motivation for the study of astronomy, and they produced many outstanding astronomers and mathematicians such as Thabit ibn Qurra. In 33 Muslim scholars and scientists fact Thabit was also born in Haran and would have still have been living there at the time that Al-Batani was born. Al-Batani, unlike Thabit, was not a believer in the Sabian religion, however, for Abu Allah Muhammad indicates that he was certainly a Muslim. Although the identification is not absolutely certain, it is probable that Al-Batani's father was Jabir ibn Sinan al-Harani, who had a high reputation as an instrument maker in Haran. The name certainly makes the identification fairly certain, and the fact that Al-Batani himself was skilled in making astronomical instruments is a good indication that he learnt these skills from his father. Al-Batani made his remarkably accurate astronomical observations at Antioch and Ar-Raqqa in Syria. The town of Ar-Raqqa, where most of Al-Batani's observations were made, became prosperous when Harun al-Rashid, who became the 5th caliph of the Abbasid dynasty on 14 September 786, built several palaces there. The town had been renamed al-Rashid at that time, but, by the time Al-Batani began observing there, it had reverted to the name of Ar-Raqqa. The town was on the Euphrates River just west of where it joins the Balak River, on which Haran stands. The Fihrist Index was a work compiled by the bookseller Ibn an-Nadim in 988. It gives a full account of the Arabic literature which was available in the 10th century, and it describes briefly some of the authors of this literature. The Fihrist describes Al-Batani as, see for example, 1-1 of the famous observers and a leader in geometry, theoretical and practical astronomy, and astrology. He composed a work on astronomy, with tables, containing his own observations of the sun and moon and a more accurate description of their motions than that given in Ptolemy's Almagest. In it, moreover, he gives 34 Muslim scholars and scientists the motions of the 5 planets, with the improved observations he succeeded in making, as well as other necessary astronomical calculations. Some of his observations mentioned in his Book of Tables were made in the year 880 and later on in the year 900. Nobody is known in Islam who reached similar perfection in observing the stars and scrutinizing their motions. Apart from this, he took great interest in astrology, which led him to write on this subject too. Of his compositions in this field I mention his commentary on Ptolemy's Tetrabiblos. Other information about Al-Batani contained in the Fihrist is that he observed between the years 877 and 918, and that his star catalogue is based on the year 880. It also describes the end of his life, which seems to have occurred during a journey he made to Baghdad to protest on behalf of a group of people from Ar-Raqqa because they had been unfairly taxed. Al-Batani reached Baghdad and put his arguments but died on the return journey to Ar-Raqqa. The Fihrist also quotes a number of works by Al-Batani. There is his Kitab al-Zid, which is his major work on astronomy with tables, referred to above. We shall examine this in more detail in a moment. There is also the commentary on Ptolemy's Tetrabiblos referred to above, and 2 other titles, on ascensions of the signs of the zodiac and on the quantities of the astrological applications. One of the chapters of the Kitab al-Zij has the title on ascensions of the signs of the zodiac, and so the Fiist may be wrong in thinking this is a separate work. This point still appears unclear. Albatani's Kitab al-Zij is by far his most important work, and we should examine briefly the topics which it covered. The work contained 57 chapters. It begins with a description of the division of the celestial sphere into the signs of the zodiac and into degrees. The necessary background mathematical tools are then introduced, such as the arithmetical operations on sexagesimal 35 Muslim scholars and scientists' fractions and the trigonometric functions. Chapter 4 contains data from Albatani's own observations. Chapters 5 to 26 discuss a large number of different astronomical problems following to some extent material from the Almagest. The motions of the Sun, Moon and 5 planets are discussed in chapters 27 to 31, where the theory given is that of Ptolemy, but for Albatani the theory appears less important than the practical aspects. After giving results to allow data given for one era to be converted to another era, Albatani then gives 16 chapters which explain how his tables are to be read. Chapters 49 to 55 cover problems in astrology, while chapter 56 discusses the construction of a sundial and the final chapter discusses the construction of a number of astronomical instruments. What are the main achievements of Albatani's Zij? He catalogued 489 stars. He refined the existing values for the length of the year, which he gave as 365 days 5 hours 48 minutes 24 seconds. And of the seasons, he calculated 54.5 per year for the precession of the equinoxes and obtained the value of 2335 for the inclination of the ecliptic. Rather than using geometrical methods, as Ptolemy had done, Albatani used trigonometrical methods, which were an important advance. For example, he gives important trigonometric formulas for right-angled triangles such as b sin a equals a sin 90. Albatani showed that the farthest distance of the Sun from the Earth varies and, as a result, annular eclipses of the Sun are possible as well as total eclipses. However, as Swerdlow points out in 8, the influence of Ptolemy was remarkably strong on all medieval authors, and even a brilliant scientist like Albatani probably did not dare to claim a different value of the distance from the Earth to the Sun from that given by Ptolemy. This was 36 Muslim scholars and scientists, despite the fact that Albatani could deduce a value for the distance from his own observations that differed greatly from Ptolemy's. In 1, Hartner gives a somewhat different opinion of the way that Albatani is influenced by Ptolemy. He writes: while Albatani takes no critical attitude towards the Ptolemaic kinematics in general, he evidences a very sound skepticism in regard to Ptolemy's practical results. Thus, relying on his own observations, he corrects, be it tacitly, be it in open words, Ptolemy's errors. This concerns the main parameters of planetary motion no less than erroneous conclusions drawn from insufficient or faulty observations, such as the invariability of the obliquity of the ecliptic or of the solar apogee. Albatani is important in the development of science for a number of reasons, but one of these must be the large influence his work had on scientists such as Tycho Brahe, Kepler, Galileo and Copernicus. In 5, there is a discussion on how Albatani managed to produce more accurate measurements of the motion of the Sun than did Copernicus. The author suggests that Albatani obtained much more accurate results simply because his observations were made from a more southerly latitude. For Albatani, refraction had little effect on his meridian observations at the winter solstice because, at his more southerly side of Araka, the Sun was higher in the sky. Albatani's Kitab al-Zij was translated into Latin as De Mata Stellarum, on the motion of the stars, by Plato of Tivoli. This appeared in 1116, while a printed edition of Plato of Tivoli's translation appeared in 1537 and then again in 1645. A Spanish translation was made in the 13th century, and both it and Plato of Tivoli's Latin translation have survived.